Hi everybody, it's 8 o'clock and we're just about ready to start the webinar. Hopefully you can hear me all right. Hopefully, Barbara, you're there. Oh, maybe not just yet. Hopefully Barbara will join us.
Yes, I'm there.
Oh,
yeah.
You are. Hi Barbara, that's great. Thank you. So everybody, we're delighted to have Barbara Monks with us this evening to do a webinar on the functional properties of carbohydrates. So Barbara's got this fantastic wealth of knowledge about food science and great experience of being a food teacher and head of department and lots of other roles within schools. So we're looking forward to what will be a really good, very informative webinar with lots of information and lots of top tips to help you with food science in your classrooms. So just a little bit about housekeeping before I hand over to Barbara. So as we've mentioned before, please make sure that your chat box is set to panelists and attendees. That way everybody can see all of the questions, not just us as the presenters. That would be great. And then just thinking about housekeeping. So the webinar is being recorded and will be available for future use on the Food A Fact of Life website. Hopefully we'll be able to get that up there first thing tomorrow morning. So as I mentioned before, if you've got any questions, please type them in the chat box and they'll be answered at the end. And if you've got anything particularly, make sure that you put that in there. If there's something that perhaps Barbara can't answer this evening or we run out of time, we can always get back to you via email afterwards. And then at the end of the webinar, you'll be redirected to a short online evaluation. That will only take you about a minute to complete. Once you've done that, and that would be really helpful to us if you could do it, you'll then be redirected to a downloadable certificate. Please download that and then add your name to it and then print it for your records. So there's a little bit of a delay, just so you know, so that Barbara will be talking to her slides, but there may be just a little bit of delay just as we go through them. But that's my introductory bit done, Barbara. So over to you now.
Okay, well, hi everybody, and thank you, Alex and Francis, for supporting me with the technology for this evening's webinar. My name's Barbara Monks, and I know I should be probably typing into the chat box to say a huge hi to everyone, but I never quite get round to that. So in my heart, I'm saying a big hi to you all, and I'm delighted that you're joining me tonight. Well, this is the first slide, and this was the most challenging slide of the whole presentation because I saw a cookie stamp in a museum shop and I thought to myself, oh, that would be just the thing. I can stamp it out onto a piece of toast and it'll say the word carbohydrate really nicely. But no, it was so difficult, really fiddly, and it's not even that easy to read, is it? It's a nice idea, as they say. But anyway, it starts the topic for tonight, the function of carbohydrates. See if the slide goes on. Come on. Are we getting our slide? Oh, there we go. So what's going to be covered tonight? Well, in the webinar, we're going to look at why it's important to know about the function of ingredients, the functional properties of carbohydrates, teaching food science through practical activities focusing on carbohydrates, and how to build knowledge and incorporate more functions in practical work. There'll be some suggestions for further reading and sources of information and links to Food A Fact of Life from their lovely new website. I'll use my years of experience as a food teacher and in-depth knowledge of food science to highlight why it's a good idea to include functions of ingredients for successful teaching. I want to give plenty of ideas as to how food science can be incorporated regularly into practical activities in the classroom. So let's start with carbohydrate. Carbohydrate is an essential in the diet. Carbohydrates are the best way to provide fuel for the body because there are lots of foods to choose from. They're readily available throughout the year, they're easy to purchase and easy to store. It's important to distinguish between types and quality of carbohydrate. Sugars, chemically known as monosaccharides and disaccharides, supply energy, but little else, and have a detrimental effect on teeth, and when consumed in excess, can contribute to obesity and other health problems. Starches, chemically known as polysaccharides, are composed of amylose and amylopectin and provide energy and many micronutrients. Starchy ingredients not only provide carbohydrate, but they deliver the micronutrients such as white flour is fortified with iron, vitamin B1, thiamine and niacin, and potatoes provide valuable vitamin C, particularly through the winter months. And furthermore, where less refined whole grain starches are selected, there's an enormous benefit to be had from the dietary fibre that they contain. If dietary choices are to be made for healthy, active people, then starchy carbohydrates in all forms is a good choice. As food teachers, we know this topic is currently being tackled by some students as part of their GCSE assessments. So it's important that they consider the health functions of carbohydrate. And one of the main health functions is to provide energy. Take a look at the excellent presentation from www.foodeffectivelife.org for further information about energy needs. Find it in the 11 to 14 years section. There's an activity presentation and worksheets, and also physical activity guidelines. And you can use the physical activity guidelines in your school discussions, because the sad fact is that only 1 in 4 boys and 1 in 5 girls meet these guidelines at present. So by using these presentations, we can learn that 1 gram of any type of carbohydrate supplies about 4 kilocalories. And carbohydrates as sugars are very efficient in delivering their energy supply, being absorbed through the stomach and not requiring any further digestion. So they act really quickly in raising blood sugars and supplying energy. Carbohydrate as starch is different. We need to remember that raw starch is not digestible. So it is the act of cooking that renders starch digestible and thus able to supply us calories. So the type and quality of carbohydrate selected for dietary consumption is important. Carbohydrates are a big group of foods and can be divided into 2 main groups, starches and sugars. Starches, as I've said, are long-chain polysaccharides containing amylose and amylopectin molecules. Non-starch polysaccharides, often referred to as NSP, you'll see that on the slide, are also within this group and commonly known as dietary fibres, and they offer definite nutritional functions rather than cooking functions. Sugars can be monosaccharides such as glucose or fructose, that's fruit sugar, or disaccharides such as sucrose, lactose and maltose. Lactose is the sugar in milk, and sucrose is the main disaccharide for the purpose of looking at carbohydrate functionality, because it forms all those sugary ingredients coming from sugar cane and sugar beet, crystals of granulated sugar, castor or baking sugar, brown sugars and syrups. If we look at this slide, we've got an overview of the function of carbohydrates. We've got starchy ingredients such as flour, potatoes, rice, pasta and bread on one side of the triangle, and sugars through sugary ingredients such as white and golden and brown sugars. And we can see that they offer a huge variety of functions. Both starches and sugars are bulking ingredients. I put that at the top. They're ingredients used in large amounts by weight and proportion of recipes. Generally, carbohydrates are cheap ingredients, readily available for us to use and choose in our cooking. It's what happens when we use carbohydrate ingredients that exemplifies their active and functional properties. We see them enable browning, either by starch, dextranization, or sugar, caramelization. We can also see starches permitting thickening due to gelatinization, or gelatinization enables softening and improved digestibility and tenderizing, as in the case of potatoes, rice and pasta. Preserving is enabled when sugar in large enough proportion is used, and sugars assist in fermentation. Finally, we can see that starches add other micronutrients in the diet, as we've already noted, and generally both starchy and sugary carbohydrates add a wealth of choice to the diet. There are so many starchy foods and ingredients used all around the world, to make interesting meals at affordable prices. And much of the time, in our cooking, both types of carbohydrates are mixed in varying proportions to maximise their functionality. Outside the triangle, I've noted the non-starch polysaccharide, known as dietary fibre, which definitely adds function via nutritional pathways, making whole grain versions of flour, oats, pasta and rice excellent dietary choices. I hope this triangular shape represents a good summary of the functions that carbohydrates perform in food preparation and cooking. The key ones for food science are those relating to browning, that's dextranization and caramelization. Those related to thickening through gelatinization of starch, and those that aid fermentation and preservation. And finally, the functionality seen when ingredients are combined to achieve flavours, textures, colours, tastes and appearances characteristic to baking and other cooking techniques. So now I'm going to move into the actual functions of carbohydrates. And the first one is dextranization. This is the colour enhancing function of starchy carbohydrate known as dextranization, and it's exemplified in exam specifications as browning of bread when baking and when preparing and cooking food such as pastries and bread. So students need to be familiar with this term. How we best teach dextranization depends on a number of things, mainly directed by your own knowledge of the students that you teach. Some students love to get to grips with long words and others just go blank. But all students need support and reminders via word banks and keyword charts and, I believe, practical experiences related to the function. My technique on this slide and on the ones that follow is that I've tried to present the information in an organised way using a circle divided into the 4 quarters. In the first quarter, I put the key term, the key word. And in the second quarter, a brief explanation of the carbohydrate function. Following that, in the third quarter, I've put some of the main working characteristics of the function that we might notice in practical situations. And in the final 4th quarter, I've included some examples of recipes or products that would illuminate the function. Around the centre circle, I've selected a recipe or 2 from the new jam-packed full Food Effective Life website. I must say well done to the team at BNF for all the work that they put in creating this new version of the website for us to use free of charge. And we can now collect our favourites and regular go-to sheets in our very own dashboard, which can be organised into groups and files. It's brilliant for speedy working and busy teachers. So back to the food science term dextranization. This is surface browning. In other words, the changes in coloration of starchy carbohydrate brought about by direct heat, such as a grill or a toaster in particular, and also from dry oven heat or baking that brings about browning. We can see that change, which is most helpful in a food room lesson. Look at the differences between uncooked and cooked. Most students are really good at picking out what they see. Golden parts, goldenness, browner tinges, darker patches, becoming darker, even burnt. Well, sometimes that's detected by the smoke alarm or even your nose. How many times have you said, there's something burning in this room, check your ovens? Dextranization is browning of starch by dry heat. Remember that steamed foods don't readily go brown. The starch simply gelatinizes and remains pale. The polysaccharide chain breaks down to shorter chains due to the heat, known as dextrins. Dextrins are not only coloured, but they're also sweeter, making the product tastier. And there's a change of texture. We get crunchier, crispier textures that can be detected by mouthfeel. My examples are recipes that you might make in the food room. Toast for toasted snacks, croutons for soups, or short crust pastry or baked biscuits and scone-based pizza. Obviously, toast is a simple demonstration of dextranization and an easy to remember function of heat on starchy carbohydrate. Where biscuits are chosen, remember that these recipes combine both starchy and sugary carbohydrates in significant amounts. So we need to be aware of the different types of browning going on. And that takes us nicely to the next function of carbohydrate, that of caramelization. So here's the page on caramelization. Again, this is a browning function mentioned in specifications for the GCSE food preparation nutrition under making skills as the caramelization of vegetables, be it parsnips, onions or beetroot. So it's really nice to be aware of savoury examples of caramelization. That's because many vegetables do contain sugar within their cellular structures, and when they react to heat, especially when fat or oil is present, they can caramelize beautifully. Onions, for example. First of all, the heat drives off the water that they contain. You'll hear that as sizzling. And then the juices are squeezed out and are concentrated and reduced. And finally, browning occurs with a sweeter flavour. Good examples of this is when preparing and cooking French onion soup. Oh, well, perhaps that's a good new recipe for the website. But anyway, it's on my website, thecookeryteacher.com. Sugary carbohydrates caramelize readily too when heat is used. Manipulating browning, aiming at getting just the right amount of colour and flavour, is really quite skillful. Creme caramel or creme brulee demonstrates utilising this function of sugary carbohydrate. A pale syrup is merely sweet, whereas a darker sugar syrup brings complex flavours and a thicker syrupy juice for the pudding. If it's not controlled, the syrup can blacken and burn, giving a very bitter taste that's unpleasant. It's skillful getting it just right. Many European countries have their version of the ever popular creme brulee or creme caramel, simply based on eggs, milk, cream and sugar. Sometimes in food preparation and cooking, the function of caramelization is brought about through mixtures of ingredients, as in cakes, biscuits, flapjack or granola bars. And usually this is via baking in dry heat. What is seen and what can be visibly observed is that browning, the change from white sugar crystals to richer brown and golden brown attributes, is brought about by the controlled use of time and temperature working together to get the desired brownness. How many recipes say cook till golden brown? Making caramel from sugar alone shouldn't be overlooked. It's used in many cuisines around the world. Caramel drizzled sticky potatoes in China, croquembouche in France, candies in America. And let's not forget the excitement of learning how to make golden sponge sugar delights to enhance desserts. It's a spectacular function and one our students at Key Stage 4 like to demonstrate as their showstopper. And now the Maillard reaction. I wondered really if I would confuse by including the Maillard reaction in this presentation on carbohydrates. But if I don't mention it, I thought you'd probably ask. So I've put it in because it's not really a clear function of carbohydrate. It's rather complex. It is browning. I used to teach it only related to meat, the outer layer of roasted meat, demonstrating the Maillard reaction really clearly. Juices from meat containing sugars, muscular sugars and blood sugars, and proteins. And together these, in the presence of dry heat, brown and become sweeter, which is why the outer slice of meat tastes so delicious. Well, maybe these days it's more likely to be noticed on a well-cooked burger. We're unlikely to be doing a roasting a big joint of meat in a food room. But let's be clear, the Maillard reaction is a reaction brought about between the reducing sugar, glucose, fructose or maltose, and an amino group of the protein molecule. Its occurrence is in dry, the outer exposed layer, remember, of the meat, rather than the moist internal conditions, and at medium or high temperatures. I've popped a couple of recipe links onto this slide for glazed pastry, cheese and onion triangles, koftas and glazed bread plats, as these are perhaps where you might just want to mention the Maillard reaction. All of these recipes are on Food A Fact of Life website for you to access. And also there's a worksheet looking specifically at the Maillard reaction that you might want to check out. Well, we'll move away from browning and have a look at gelatinization. The function of thickening is a major function of all starches. Thickening is changes in flow and consistency. and are so ubiquitous in our food preparation repertoire. Manufacturers, of course, manipulate texture in many ways using a wide range of ingredients, especially these days, ingredients like seaweed, such as carrageenan, because they maintain lovely mouthfeel while also permitting transport of products without too much sloshing about that might spoil the look of the product. But for us, our main go-to range of ingredients for changing thickness are the starches, be it plain flour, corn flour, arrowroot, or indeed barley, rice, or potato starch. The carbohydrate function is well practiced through sauce making, which is an essential skill for Key Stage 3 and upwards. Thickening starts with starch imbibing or soaking up liquid and consequently swelling. Heat and moisture is needed to complete the function of gelatinization alongside agitation, particularly during sauce making. But let's think about the chemical side of thickening. Starch is made up from amylose and amylopectin, and depending on which cereal starch you select, the proportion of amylose and amylopectin varies. So wheat flour, for example, has about 25% amylose, and therefore it will thicken the liquid perfectly if the temperature is high enough. By that I mean if bringing the sauce to the boil. This thickened mixture will flow smoothly as a poured sauce or as a coating mixture, and will also set on cooling. Amylose and amylopectin work well together to thicken and set. Where a starch has less amylose, such as in potato, the potato will thicken, for example, when making soup, but it doesn't set on cooling. Agitation or stirring is an important essential skill used in sauce making to prevent lumps forming and to maintain a smooth sauce. Fat, used in a roux, acts to prevent wheat flour starch grains clumping, whereas in a blended sauce, where the selected starch is corn flour, the starch will slake with water easily, for example in a white sauce or a custard powder. Other variations of starch grains can influence whether the end sauce is cloudy or clear. Arrowroot is often chosen for its ability to produce a clear sauce for glazing fruits, flans or tartlets, and the shine is assisted by the addition of sugar to sweeten the sauce. Making a blended white sauce, a roux, velouté or bechamel sauce will demonstrate to students just how the liquid starch ratios affect viscosity and help students understand starch gelatinization. Most students learn to make a roux or an all-in-one blended sauce or infused sauce during Key Stage 3 and 4. Not only do they then know about gelatinization, but they also understand how conduction and convection work together to cook the sauce, and that there is a real need for agitation. I've included the macaroni cheese recipe on this page and also roux sauce, and some potato information sheets, as cooking potato is also learning about starches being gelatinized, make it tender and to make potato digestible. There's a wealth of material on Food Effective Life website to help you teach around potatoes, from farm to fork, different varieties and how they're grown, and lots of ways to cook potatoes. And now to another function, fermentation. This slide covers a function of sugar initially, because it's sugar that will supply energy for yeast to ferment and produce carbon dioxide. Usually we're teaching something like bread dough for pizza bases or plain bread rolls, when a teaspoon of sugar can really energize the yeast. Remember now that all the grain chain recipes and worksheets are available through Food Effective Life, so you have loads of worksheets, recipes and food science information sheets available to you. When you revisit bread dough at Key Stage 4, you may choose to do more yeasted products such as hot cross buns, Chelsea buns, a Finnish fruit plat or brilliant bread, for example. All those recipes on Food Effective Life. Although sugar is the initial carbohydrate giving energy to the yeast, which is useful when lessons are rather limited in time, that sugar really does give an early boost to the yeast. But also during proving, remember that the starch from the flour changes due to enzyme activity, and this also enables the yeast to ferment and to raise the dough with the carbon dioxide gas. What a lot we can learn from making simple bread rolls. Well, that brings me to preservation. Sugar as a disaccharide has a function in helping to preserve food, in particular perhaps seasonal fruits. And there's a lovely PowerPoint presentation available on seasonality in both the 11 to 14 year and 14 to 16 section on the Food Effective Life website. And it would be really useful to use that to identify which fruits at which times of the year could easily be preserved. Jam making has stood the test of time, as has marmalade and lemon curd. Nothing has the flavour of homemade preserves, or indeed the brightness of colour when preserving sugar is used on colourful fruit like red currants, raspberries, strawberries. Sugar reliably holds water when it's used in high enough concentrations. And in jam, that's usually 65% sugar. Hence, jam will store out of the refrigerator, whereas conserve or low sugar jams, they're often a softer set and more watery and need the extra support of refrigeration during storage, as they contain a lower percentage of sugar. While sugar is the active preservative preventing water activity that's so needed by microbes, pectin and acid are also required to help a jam set properly. There's quite a lot to learn through making a small quantity of jam or other preserves, but the secret is getting the recipe right and trialling just how much you're going to be making and whether your pans are the right size, and indeed whether perhaps the microwave method would be best for you to use. Meringues are egg whites whipped with sugar in a high proportion, and if dried thoroughly, they have a long shelf life, and in essence they're preserved. Small meringues are fun to make and dry off relatively quickly. Sugar not only helps the keeping qualities of the egg white, but also plays an important role in foam formation and stability. So now I'm just going to take a broader look at carbohydrates and their contribution to variety in the diet. And I'm starting this by looking at sugars. We can see that our diet has a multitude of different textures, colours, flavours, appearances, due particularly to sugary ingredients being used. In many Asian savoury dishes, a small amount of sugar is added to complement flavours from spices. And sugar enables decorative, colourful foods, and sometimes adds crunch, which is a very desirable sensory property. Whilst avoiding regular intake of sugar, there are some functions of sugar that enhance celebratory events, such as parties and celebrations. Our students enjoy this sort of work, and we can see how sugar will enable creaming, aeration, and tenderizing the crumb when combining ingredients in different methods of cake making. The popularity of soft, squidgy brownies also comes from increasing the amount of sugar in the recipe and the selection of a specific sugar type, such as soft brown sugar, to create moist and gooey-scented products. If we look at starch in the same way, we can see that starch contributes to variety in the diet. Starchy food and starchy ingredients also add sensory properties to our diet, giving masses of variety of colour, flavour, texture and appearance. Just think about the texture range that comes from selecting different types of bread, white to granary to whole grain, flatbreads, sourdough, pretzels and many, many more choices. Or the wonderful range of pasta shapes and sizes that enrich our eating. Or rice too, from basmati to sticky Thai or perfumed jasmine rice, or indeed the several types of risotto rice. And potatoes, I'll mention them again. There's so much to learn about this regional crop, offering us floury, waxy or new potatoes for use in a variety of ways. And all these carbohydrates offer variety in the diet through their wide range of shapes, colours, flavours and textures. What a massive function that is in terms of our sensory experiences of food. So I said I'd suggest some further resources, but honestly it's hard not just to say use Food Effective Life. I think this is a screen grab from the website, which actually shows the carbohydrate resources that you've already got on the website and their functional properties. And it's all there, ready for the classroom. How good is that? Of course, not only carbohydrates are covered, but also fats and proteins come in this format too. All these presentations are accompanied by worksheets for students to check their learning. All the PowerPoints are clear and concise and cover essential food science detailing the composition of carbohydrates, proteins and fats and what happens when they're cooked. Make no mistake, these resources stand the test of time. They make revision easy and the worksheets are exam appropriate. I dip around and have favourites from the early years alongside some of the 14 to 16 year section. The recipe range on this new Food Effective Life website is extensive, and look also at the quizzes, because these are just what you need for classroom revision or homework or quick-fire questioning. So I'm going to sort of end tonight's webinar by covering just a few tips on how you can help your students build knowledge and incorporate more functions and skills into practical work. I know there's an issue of showing enough skills. It's pertinent to many teachers. Skills in cooking enable functions of ingredients to be understood. So there's a relationship between the two aspects of food teaching that should be mutually beneficial. As I said at the start, I would look at how to build knowledge and incorporate more functions into practical work. So here are a few of my top tips. Firstly, tip number 1, simply tagging each of your recipes with key functions performed by the main ingredients is, I think, very fundamental. It doesn't take long, and it could simply be achieved by sticking a strip along the bottom of a recipe sheet so that when it's photocopied, the additional information is there, or adjusting the PDF copies for your whiteboard or school intranet. So if you identify and tag a recipe with the function of its main ingredients, that would be my top tip. But as we all know, the luxury of being able to focus on just one aspect of food work is difficult, as we don't have the students for an awful lot of time. And therefore, I would recommend you tag more key messages for each recipe if you could. I'll just change the slide and put this one up. Some teachers like to use this 5-star page. I've shared it previously when I've been presenting to teachers. Each of the points of the 5-star will lead to key information that could be tagged to a recipe, such as a key point linking to the Eat Well guide or nutrition fact, a key point that picks up on skills in food preparation or cooking method or maybe heat transfer, a key food science term, as I've just mentioned, and something that links the recipe with food safety. And finally, something that draws attention to perhaps sustainability, food provenance, seasonality, or consumer food choices. This page could be inserted next to each recipe used and even displayed on a notice board, and would help remind students of the key learning that was linked to the recipe in that lesson. But back to the top tips. So the second top tip is to remember the importance to teach students to observe and notice how we transform ingredients through our cooking. If we're making some of the recipes from Food Effective Life or similar, we might be making something like cheese and onion triangles or tomato and basil tart or Dutch apple cake. And through these recipes, we can see how carbohydrates function. Oops, just lost my page, hang on a minute. We can see how the carbohydrates function during cooking. We can notice coloration changes due to heat, texture changes due to cooking. For example, where pliable pastry becomes rigid in structure, so it'll hold a filling. And pointing out these changes and getting your students to notice and observe the changes is reinforcing the learning about the function of ingredients and why we use them. Well, tip 3 is about building skills. And as we introduce a dish at Key Stage 3 or earlier, then we'd be using a standalone recipe. But later, when more skills are needed, as in Key Stage 4, combining and adding dishes together will extend the skill range. So, for example, cheesy scones could become an accompaniment for mozzarella meatballs. Samosas could go well with lamb korma, as would raita. Tomato and bean and pasta soup would go nicely with tortilla toasties, and so on. And in order not to increase cost too much, remember the extra recipes could be shared by 2 or 3 students doing group work. Or the recipe amounts could be reduced, as half a recipe would be more than enough if the end result is an accompaniment rather than a main dish. And also mini versions could work well, tiny pasties, sliced strips of flatbread, and mini portions of cauliflower cheese on the side. In this way, multiple skills and more complex skills can be shown. Potato and courgette frittata, potato salads, potato and cheese scones, potato gratin, and potato and spring onion cakes show just some of the exciting affordable potato recipes available on Food Effective Life that can be added as sides and accompaniments to other recipes. Tip 4 is adding a sauce. Well, that's got to be a winner, hasn't it? Incorporating a sauce adds skills and adds more ingredients that function. Roux sauce, bechamel sauce, or velouté sauce, for example, over vegetables, pastas, or fish dishes. Parsley sauce over potato, scotch egg, and so on. Be imaginative. This photo shows a custard layer within the simple apple and sultana crumble, combining and increasing the skill level while also extending learning of the function of ingredients. Tip 5, my final point, might be try and add a little bit of skill, decorative or garnish piece to the chosen dish. Maybe when filleting a fish, that could be accompanied by homemade flavoured butter pat. Again, it could be group work in the class for the butter production, or individual choice for flavouring, such as adding chopped parsley or herbs to get some knife skills in, or making parmesan crisps or small decorative snippets of pastry or even croutons to garnish a dish. They'll improve the presentation and extend skills and knowledge. Well, that brings me almost to the end of the webinar. Thanks very much for taking part. Thanks for being with me tonight. It's been helpful. It's nice knowing you there. I can see the chat box has been quite active. I hope the presentation has covered the importance of the function of ingredients and functional properties of carbohydrates, and has helped you think of ways to teach and include food science through your practical activities. I hope the PowerPoint slides that encompass the key food terms, carbohydrate function, working characteristics, and examples are useful to you. And I hope I've drawn attention to all the brilliant resources on Food Effective Life. There is this next slide, I think. Yes, there is this next slide that you could read yourself to show you some extra bits of reading that might be useful to you. And I think at this stage, I pass back over to Alex and Francis, the team in London, to deal with the rest of the slides on the webinar tonight. But I might be back in a mo if we've got any unanswered questions. But for now, I'll say goodbye and pass you back to the London team at Food Effective Life. And thanks.
Thank you very much, Barbara. That was absolutely brilliant. Some wonderful points that you've covered there, and some really interesting aspects of looking at carbohydrates, and particularly thinking at the end about how students can actually extend their practical work. So absolutely fantastic. Thank you. We have got a couple of questions, but I'll let you sit back just for a minute to get your breath, and then we'll come to you in a minute, because I do just want to just look at this slide on the screen at the moment. So as you said, other sources of information and support. So there's a few websites there. Obviously, Barbara's mentioned Food Effective Life plenty of times tonight, which has been fantastic, and it's great to know that the resources on there are appreciated. So that's really good. IFST, the Institute of Food Science and Technology, have got a really good section on their website, which is Love Food, Love Science. And thoroughly recommend that you have a look at those as well. And then sciencelearn.org. I'm not sure about that website, but that's one that Barbara has recommended. And then also use the range of textbooks and revision guides that you've got. And then on the other side of the slide is Barbara's own website, which is thecookeryteacher.com. And again, I'd thoroughly recommend you had a look at that. There's lots and lots of great information on there, lots of recipes. And as it says, every recipe has a cook's know-how. So do take the time to have a look at that if you can. And then just before we finish, just a little bit about some more training that we're going to be doing. So on the 1st of February, we've got our National Food Nutrition Conference, which is in London. That's a conference which is for primary and secondary teachers. We have actually only got 5 or 6 tickets left for that. So if you are interested in coming along, I would try and book your tickets as quickly as possible. And then we've got another webinar in March, which is a skill along, and that's our colleague Claire, who's going to be looking at cereals. And that's mainly for primary teachers, looking at use of cereals in the classroom, but would be just as suitable for secondary as well, or perhaps middle schools or special needs teachers, if anybody's interested in joining us for that one. And then we've also got lots of online training, which can be done at any time, at home or at work. and there's quite a few now we have available which are free of charge for the moment. So please do have a look and see at the wide range of courses we've got available. And then we've also got some more PPD information support and also a new newsletter sign up. So we have 2 newsletters for Food Effective Life now. One which is our monthly sort of education news, and then we've also got a new PPD one as well. So please do sign up if you'd like some more information about training and support. And then before we finish, I'm going to ask Barbara a couple of questions, but at the end when we close down the webinar, you will be taken to the survey. So if you could please complete that, that'd be fantastic. And then you'll be taken to your certificate, which you can personalize and then keep in your folders. If by any chance you're not sent directly to the SurveyMonkey evaluation, we will actually send it out tomorrow when we send you the link for the presentation and the recording of tonight's webinar. So a couple of questions, Barbara, if you're there.
Yes, I'm there.
Great. So one actually from Roy. So can Barbara give a couple of examples of experiments pupils could undertake with carbohydrates?
Well, I think one nice one that I used to do was to experiment just by cooking a little bit of pasta, say macaroni or shell shape, and just seeing how much they swell up and how much water they absorb. And that will give you a little bit of a lead into talking about gelatinization. So if you measure out some raw pasta and then cook that pasta and weigh it again and look at the visual changes, it's really quite interesting to see how much the starch absorbs the water as it begins to gelatinize.
Great, thank you. And also you mentioned about making a white sauce or a cheese sauce earlier on, and I always used to think when I was teaching that was a fantastic way of showing the starches and the functions of carbohydrates, something that's quite nice and easy to do in the classroom. Yeah, sauce making goes on in our classrooms, particularly in the secondary sector. So it's probably perhaps thinking for primary the pasta experiment might be quite nice, but in any case it fits really nice alongside doing some cooking. You know, you can do it while you're making your macaroni cheese. You could just take a little portion out and do a little weigh in and look at the differences that happen as you begin to heat it up and put it in water. Great, that's fantastic, thank you. And then just one other actually. So this one is, if you are short of time in practical lessons, is there a recipe that you would recommend that would show the functions of carbohydrates really well? Oof, well, everybody's short on time, really short on time. I know that is a problem for all teachers. We haven't got enough time, have we? I mean, I was just looking the other day at the school I used to teach at was showing their little scone-based pizza snacks that they'd made, and that's a lovely little recipe to do, because you don't need to make a huge big pizza shape. You can make small shapes and you can add lots of other ingredients, and you'll be dealing with rubbing in fat flour and mixing a dough, so you can talk about carbohydrates there. And sometimes people put a little bit of semolina onto the work unit to stop pizzas sticking when they're cooked, and then you can bake that recipe off quickly, and you'll see the changes between raw pliable dough and a more rigid dough when it's carrying ingredients. So something simple like scones or scone-based pizzas would be lovely. That's great, thank you. I think that's a really nice suggestion, something that a bit like your pasta, really, something that's quite sort of cheap and easy to do, but has got a really good outcome to it. So thank you very much. So everybody, we're coming to the end of the webinar now. I just wanted to say thank you so much to Barbara. That was a brilliant webinar. Thank you, and thank you for giving up your evening and for obviously all the time that you spent getting this ready for presenting this evening. So thank you very much. Thank you very much, everybody else. Have a great evening, and we'll see you again soon. Bye-bye.
Bye.